All right, this is Techmath1. We're looking at 12.7 and chapter 12 of the book. And so we're doing Law of Cosines. So that is, take a look at number 46 on page 523, 12.7, the Law of Cosines. So they give us this figure and they tell us to find P. This is P, this is 60 degrees, this angle P. This is 800 meters, that's F. And this is 500 meters, that's D, little d. And then that's capital F and that's capital D. Okay, so what we have here is an angle, a side, an angle, and a side. We can't use the law of sines because to do sines, we need like the angles, right? The angle opposite and the side opposite. So I don't know that and I don't know that. So, and I can't use Pythagorean's theorem, a squared plus b squared equals c squared, because that's not 90, that's 60, all right? So how do we do it then? Well, let's take a look. We're going to use the law of cosines, and initially this looks really bad, but it's not as bad as it looks. The side that you're trying to find is always the one that's isolated. So if we changed up the letters, we would say p squared equals, it doesn't matter which one comes first or second in this scenario. So I'm just going to say f squared plus d squared minus, and then see, these are over on this side. 2 is a constant, it's always 2. And then FD, and then the cosine of, it's always the angle from the opposite side that you're looking for, so P. And so now we're gonna plug and chug, so P squared, F, we know that's 800 squared, so that's gonna be pretty big, plus D, that's 500 squared, that's gonna be pretty big, minus 2 times 800 times 500 times the cosine of 60 degrees. So really, all of this stuff is just things that you can type that into your calculator in one shot and hit enter and get a number, all right? We'll break it down for you here like we're writing it down, but usually I don't write this down. 250,000 plus 640,000. Oh, I got those switched around. Sorry. 6425. Okay. So 250,000, 640,000, that's 800 squared and 500 squared. And then minus, when you multiply all that out, you get 400,000. And so P squared is equal to 490,000. And then you take the square root of that. So remember, our algebra would be plus or minus the square root, but negatives, lengths, they don't mix, so that goes away. And just the square root of is fine. And so that is going to be 700 meters. And that's the law of cosines. So when you have two sides and only one angle, you can, and it isn't a right angle, you can use the law of cosines. This will work every time. Sine, remember I told you about sine having an ambiguous case with the acute or the obtuse triangle. This doesn't. This will work every time, no matter what. So those are locked in. All right. Let's look at 12.8, using the law of cosines to find sides and angles. So we'll use it to find an angle instead. Look at number 56. So what if you have a triangle given and they have given you all three sides and no angles? So you didn't know the three sides but no angles. So this is 12.8 and we're doing number 56. And here's a pretty picture, and this is 6.3 meters, 9.8 meters, and 8.7. Is it an 8? Yep, 8.7 meters. All right. And then they've got A and V and G. And they want me to find angle V. So it says so find angle V eventually is what they want. So they basically said, let's rewrite this with these letters in it, okay? So that means side V, now we can label these. Oh, they actually have them labeled too. V is equal to, and little a is equal to, and little g is equal to. So they've got those actually on their diagram. So they said, okay, rewrite this, the law of cosines, but use these letters instead. And that's fine. The one we're going to focus in on is V. So we'll put V squared is equal to, and that can still be A squared, and the other one is going to be G squared instead of V. They didn't use A, B, and C. They used A, V, and G. And then minus 2, and those are going to stay on that side, AG, and then the cosine of angle B, okay? So that's part A. Part B is solve for cosine of V. So they want me to solve for this. So now you got to go back to your sweet algebra skills. Remember isolating the cosine of V, basically we're treating this like the variable. So that means we would subtract A squared from both sides. Then we would subtract G squared from both sides. Okay, then we would divide both sides by negative 2AG. And so I'm sure they distribute the negative. I don't really care if you distribute the negative. They do though. So what that means is they take this negative, they multiply the bottom by -1 and the top by -1. And when they do the top by -1, they distribute it. So it's negative V squared plus A squared plus G squared over 2AG. It's fine if you just leave the negative on the 2. It doesn't matter. It's going to work out to be the same. All right. So that was part B. They wanted us to solve for the cosine of V. And now they want me to actually find the angle. So no problem. So we're going to take all of this information and jam it in here. And we've got it all nice and neat here. So we've got the opposite of V squared. So that's not in parentheses. So it's the opposite of whatever the V squared is. So 6.3 squared plus 8.7 squared plus 9.8 squared all over 2 times 8.7 times 9.8. And so when you put that into your calculator, here, we can do it. We'll do the top first and then the bottom. This is a complicated problem. This is equal to the cosine of V. So even when we find this decimal, we're not done. We then have to take the arc cosine of it. So we're going to go 8.7 squared plus 9.8 squared minus 6.3 squared. So that's 132.04 on the top. On the bottom, 2 times 8.7 times 9.8 is 170.52. And if you take 132.04 divided by answer, we get 0.77433732211. That's what the cosine of V is equal to. And so now we take the arc cosine. So the cosine of -1 of 0.77433732211. And so you pop that in your calculator, do second cosine, and then second and the negative sign, which is answer, and That gives you 39.25, so we'll round it to the nearest degree. 39 degrees. So that is quite a task, right? To do this with, to find a missing angle given all three sides. And now we could find any of the angles too. We could have done the same thing with A. It's just then it would be A squared over here, C squared would be there, C would be there, and that would be the cosine of A, the angle A. So you can work it for any different angle you want, okay? So let's look at 12.9, obtuse angles in the law of sines. I just want to look at number 62. It talks about the ambiguous case. It also says we'll work that a little bit more in Techmath1. So we're going to kind of put a pin in it. I just want you aware of it in Techmath1 here, okay? So we're not going to throw any ambiguous case problems at you in Techmath1. And so it just basically says, hey, look, if you take, because of how sine works, I'll start trig class, you know, sine is positive in the first and the second quadrant. And so if you think about how sine is, if I take the sine of 30 degrees and I take the sine of 150 degrees, that has a reference angle of 30 degrees in the second quadrant, I would get the exact same answer. The sine of 30 and the sine of 150 is exactly the same. And because of that, that's how you can run into the ambiguous case, where it gives you the wrong answer. It gives you the one, you might be looking for this one, 30, and it might kick out 150. And then you have to know it's, you know, 180 minus that to get the correct answer. All right. And so that's basically what they outlined there. And they said, go ahead, try it on your calculator, do the sine of 93 degrees and do the sine of 87 degrees, and you'll get the exact same thing, because 87 degrees in the first quadrant is the same as 93 degrees in the second quadrant. And both of them are 0.9986295. And so you got to be careful that you find the actual angle that you're looking for when you're using the law of sines. That's not a thing with law of cosines. So law of cosines is no problem. Let's get 12.10, obtuse angles in the law of cosines. So like number 70. Oh, that's just what we just did. I mean, I guess we can do one more of those. So here, we'll set it up without having the a squared and the equals, all that stuff that was here. So look at number 70. Oh, they already have it set up for you. D squared plus h squared minus 2dh cosine g. And they give you this triangle. And we got 2.4 there, 5.7 there, 7.0 there. This is g. And this is D, and this is H, and this is big H, and this is big G, and this is big D. All right? So it says rearrange the formula, so it's cosine G. So we'll do this a little faster. We're going to do minus D squared minus H squared at the same time. So we got G squared minus D squared minus H squared is equal to negative 2 DH cosine G. We divide both sides by negative 2 DH, negative 2 DH, and so we have the cosine of G is equal to this. Now this is fine. You can leave it like that if you want. Take negative 2. You'll end up with a negative divided by negative, and it'll still be a positive, okay? If that bugs you, you can multiply the top and the bottom by a negative 1, and they rearrange it. So they put this first, d squared, this second, plus h squared, this third, minus g squared, over, and we do a negative 1 on top and a negative 1 on bottom, so it's over just 2dh, okay? So that's how it really messes students up, because they look at the answer and they go, okay, wait, why did d squared come first and h squared come first? They're just saving, instead of having negative g squared plus d squared plus h squared, they're saving one, you know, they're just switching it over and they don't have to write a plus for the d squared. They saved one symbol basically by rearranging it. It's not a big deal. Okay. So now part B says, okay, plug and chug all that stuff in. So that means we're going to take this equation and put those numbers into it. So 5.7 squared plus h is 2.4 squared minus 7 squared over 2 times 5.7 times 2.4 is equal to the cosine of g. I keep writing just g. All right. So you pop all that stuff in and we can do it. Let's do it. So 5.7 squared plus 2.4 squared minus 49 equals, that's negative 10 point, oops, I did something wrong. Minus 7 squared, did I do something wrong? I got the g in the wrong spot. dh. Oh no, it's a negative one. Okay, that's okay. We're good. All right, so on the top it's negative 10.75. On the bottom, 2 times 5.7. And so divide it. So that's equal to the cosine of g, and then we take the arc cosine of that. And it gives us 113. Okay. So you can have the negative answer when you're doing the arc cosine. Strategies for solving triangles. Yeah, it depends on what they give you. Let's look at 77. When it's non-right triangles, we're usually using law of cosines or law of sines. And so here we are at 77. It says, which one would you use if they gave you t is 24.5 and the angle is 113 degrees across from it and m is 17.8, and those are in inches, and we have m and we have t and we have p. So it depends on what they ask me to find, but depending on what I'm going to use. So it says to find angle m, which law would you use? And then write the equation you would use. And so they're saying, okay, why don't you use the law of cosines so you don't run into the ambiguous case with the law of sines. All right. And we could use either, but then with the law of sines, it will end up giving us the obtuse angle, and we're going to have to find the acute angle. So, yeah, we could use either, though. So yeah, they're saying go ahead and use the law of cosines, right? The equation you would use. Okay, so they don't actually want us to find it. But if we're going to use the law of cosines to find M, angle M, this angle, that would be what? That would be 17.8 squared. Yeah, I don't know why you would do that. Is equal to oh, no. This is the law of sines. I was looking at the wrong one. I'm sorry. Okay, I was going to say, why would they try to force the law of cosines in here? They wouldn't. It's the law of sines. It's the law of sines. So it's this angle, this side, 17.8 over this angle, sine of that angle, is equal to that side, 24.5, over the sine of 113. And then that would be what you'd use. So law of sines. I was looking at 76, where they wanted you to find the side opposite given two sides and only one angle. And so that one would be the law of cosines. So 76 would be the law of cosines. 77 would be the law of sines, and I just kept looking at the wrong one. So, all right. Okay. So then let's go to the applied problem. I want to do one applied problem for you on 12.2. That's number 85. And so we can figure out which one we're going to use here. We know it's got like a river or something going across here. And they want to find the distance across the river. They labeled that F, they labeled this E, and they labeled this, is that a D, I think? D. And we know this is 200 feet, and we know this is 41 degrees, and we know this is 117 degrees. So here, let me erase that. All right, and they want to know EF. So find EF. So what would you do to find EF? Well, you would set up, that would be, again, I have this angle, this side. If I have two angles of a triangle, I have all three. Remember, that was the very first thing that we did in this chapter. So 180 degrees, if I got two angles, I got all three. That's 158. And we subtract it to find that missing angle right there. So 22 degrees. Okay, so now we know that's 22 degrees, so we can set it up and say, okay, 200 feet over the sine of 22 degrees is equal to, we'll call this side D, so I don't have EF. It's strange to use two letters for a length. So we'll just call it side D. That's what we're looking for, the distance across the lake or river, I think, river. And that is over the sine of 41 degrees. And now you don't really have to cross multiply and solve here. You can just multiply both sides by the sine of 41 degrees. And then that just cancels, and so there's your distance. So 200 sine 41 end parenthesis divided by sine 22. And let's see what we get. 200, not the right thing. 200 sine 41 degrees end parenthesis divided by sine 22 degrees. 350.26. They want me to round to the nearest foot, so 358 is the answer. All right. So that is it for chapter 12.